If you've implemented a get content activity so other apps could access files or photos from your app, your life got a lot easier in KitKat. Rather than having to implement your own activity, build a whole UI, and deal with options like multi-select, you can rely on the storage access framework and build a documents provider. A quick refresher on the storage access framework. On KitKat and higher devices, when apps start a get content intent, they'll first get a system-provided UI, courtesy of the storage access framework. This UI automatically connects to each app that provides a documents provider and gives users a consistent look and feel and functionality across all those apps. Think of it as the open dialog from a traditional operating system. Only at the end of that list of apps is any apps that use a get content activity. These document providers are like the data backends for your app. With no UI component, it's completely focused on returning a list of files and some metadata to make available to the user to select right there in the system-provided UI, even allowing users to select files from multiple documents providers at the same time. There's only 4 required methods for implementing a documents provider: query routes, query child documents, query document, and open document. A route is the entry point to your documents provider. So query routes is where you'd return metadata, like a unique route ID, the title and icon for your route for display to the user, an optional summary for maybe an account name, as well as flags for enabling optional functionalities such as returning recent items, searching, or creating new files. It also includes a document ID for the topmost directory. Turns out when we say document, it can mean 2 different things: a traditional file, something the user can open, and a directory, a folder which can contain other documents. Query child documents is where you're given a directory's document ID, and you return metadata about all of its direct children of that directory. This metadata would include document IDs, a display name, what gets shown to the user, a MIME type, and flags indicating whether it could be written, deleted, renamed, and more. You might already be guessing what query document does then. It provides the same metadata, just about a single document. It's important to note that while each document ID must be unique, the same document can appear in different directories. Say if you categorize pictures by both tags and date. Then of course you do actually need to provide the document's contents, and that's what Open Document does. Now it seems easy enough, yet when you look at the actual API, you note that many of these methods return a cursor, and many have a projection as a parameter. For those not working on databases all day, a cursor is just an interface for iterating over rows of data, with each row having a set of columns. The projection that's passed in indicates what columns are being requested by the storage access framework. And your resulting cursor should have a row for each route or document. If you don't have a database, it's totally fine. You can construct a cursor manually using a matrix cursor. You create one by passing in the projection you want to use. You'll note that a null projection parameter means you decide what fields to return, although there are some required ones for documents providers. So look through the links in the description for the details. Then for each row you want, you first create it using new row, then call add. For query routes, use the constants in the documents contract route class as the keys for each piece of data. And query child documents and query documents aren't much different, although in that case you'd use the documents contract document class for the constants. Now, for open document, you're tasked to return a parcel file descriptor. Thankfully, if you already have a local file, this is really straightforward, thanks to parcel file descriptor's open method. You can also create a parcel file descriptor directly from a socket though, so having the full local file locally isn't a hard requirement. Of course, the best implementation won't do any good unless you add your documents provider to your Android manifest. Couple things of note here. You need a unique authority for your documents provider, generally something prefaced with your application ID or package name. Then you'll need to make sure that it's exported so the storage access framework can access it. Grant URI permissions mean the system can grant permissions on your behalf. And the permission ensures only the storage access framework can connect to your documents provider. That's it for the basics. You should be able to see your root and documents when apps invoke the standard Documents UI via getContent or the actionOpenDocument intent. No more need to build your own UI, and a consistent experience whether users are operating on local files or files you provide or files from some other app. But this is really only the beginning of the storage access framework. There are optimizations for loading huge lists of document with extra loading, actionOpenDocumentTree for letting users select whole directories to share, actionCreateDocument for saving a file not just locally, but to any documents provider, providing thumbnails, document management features like deleting, renaming, copying, moving, and removing, alternate file formats, and virtual files. You'll find all the details in the links in the description on how you can use the storage access framework to build a great documents provider to build better apps.